Hi, I'm Paul. We're doing Leetcode Must Know interview questions, and today's challenge is maximum subarray. This is under the category Kadane's algorithm, although I noticed when I looked at topics that Kadane's algorithm wasn't listed there. I suppose it's a dynamic programming solution, but okay. Rating, medium. If you happen to know Kadane's algorithm, it's going to be very easy, but I suppose if you had to try to derive the algorithm on the fly, it would be at least medium difficulty. But the challenge is very simple. Simple to describe. Given an integer array, nums, find the subarray. What's a subarray? Contiguous, non-empty sequence of elements within an array. Find the subarray with the largest sum and return its sum. Okay. Well, let me see. I need a pen here. All right, so that should work. Okay, so we can use this. Example one here. The input from that. Now, Kadane's algorithm, you're going to maintain two variables. We'll call one the local variable, or the local maximum, let's say, and we'll call one the global maximum. And the global maximum is going to turn out to be the answer that we return. Now, we initialize these as whatever the first element in the array is. And the first element in this array is negative, negative 2, negative 2, and negative 2. All right. So one way that you could solve this, not a good way, but you could write a nested loop where the outer loop is the starting index and the inner loop is the ending index, and then you could iterate through every possible subarray. The reason that's not going to be a good idea, can I scroll this? Oh, gee, I can't scroll it. I can't scroll it while I have the pen on, but I can tell you I already looked at the constraints, and the constraints are that the input array would have a length somewhere between 1 and I think 10 to the 5th. Is that right? 10 to the 5th? Yeah, 10 to the 5th. So if you write it with a nested loop, then you have an n squared, you have an O of n squared algorithm. And 10 to the 5th squared is 10 to the 10th. So now you have 10 zeros, which is 10 billion. 10 billion operations. That's unlikely to work in a reasonable amount of time. Kadane's algorithm is an O of n algorithm. So that means, worst case, you've got 10,000 elements in the array, so you get 10,000 operations. Very manageable. 10,000. I'm sorry, no, 100,000. Still very manageable. Much better than 10 billion. All right. So we're going to iterate through this one element at a time. We already have the negative 2. We're going to go to 1. That's not even a good way to do that. It's too small. All right. So the local maximum for each number that we consider is the greater of the number that we're looking at, or the number that we're looking at plus the current local maximum. All right, the number that we're looking at is 1. 1 plus the local maximum is -1. So we are going to change this and say the local maximum is now 1. And because that is greater than the global maximum, we are going to change the global maximum to 1. Okay, we look at the next number. The next number is -3. -3 plus 1 is greater than -3. So the local maximum becomes -2. All right. That takes care of that number. I'm just going to mark them off this way. All right, the next number is 4. 4 is greater than 4 plus -2. So the local maximum becomes 4. Local maximum becomes 4, and because it's greater than the global maximum becomes 4. All right, let's look at the next number, -1. What is greater, -1 or -1 plus 4? All right, well, it's -1 plus 4, so that becomes 3. Okay, next number is 2. The local maximum is going to be 3 plus 2, which is greater than 3. So let's take that off, and the local maximum becomes 5. That is greater than the global maximum. So the global maximum becomes 5. Next number is 1. 5 plus 1 is greater than 1. So the local maximum, I'm just going to kind of change it like that into a 6. Again, now that is greater than the global maximum. So the global maximum also becomes 6. Go to the next number, -5. All right, -5. Well, -5 plus 6 is still greater than -5. So we're going to take this off. The local maximum is going to become 1. Okay, global maximum stays as what it is. And finally, the last number here is a 4. Add that to the local maximum, it becomes 5. Does not affect the global maximum. And so the global maximum is the number that we want to return right here, 6. And if we look at the output here, that is in fact the correct answer. All right, so that's how Kadane's algorithm works. It's a pretty elegant algorithm, and it should be a pretty simple implementation. So let's give that a try. All right, so we'll declare and initialize our variables. We'll have a variable called local max and initialize it to nums. That's our input parameter, 0, the first element of the array, and GLOB. Global max will also be initialized to the first element of the array. All right, a for loop to iterate through the array for int I equals 1. We've already handled the first element. We're going to start at the second element. For int I equals 1, I is less than nums.length I plus plus. If local max, no. Well, you know what? I mean, we're going to do that, but I forgot one line here. We've got to say local max equals math dot max. It's going to be the max of either the number that we're currently looking at, or the current local max plus the number that we're looking at. All right, mathematics. So the number or the number, yes. Okay. So now we've got a new local max. We're going to check, is the local max greater than the current global max? Actually, I guess we could do this with a math max as well, but to me, it makes more sense to do it this way. I mean, it's more obvious what we're doing. If the local max is greater than the global max, then we are going to set the global max to the local max. And once we finish that, we're going to return the global max. And I think that's it. Let's try and run it. Accepted. All right. Let's try to, it's going to be a much shorter video than the last view that we've done. Submit. I say that before submitting it, but I think it's going to work. 1 millisecond. Oh my God. All right. Well, I mean, we had some people got in there with an answer that rounded to 0, but you're not going to have a big range of run times on this because, with the exception of whatever difference a particular programming language might make, I wonder if they just, I don't know. I wonder if, like we do it in Java, if they just show the runtimes for Java. I'm not even sure about that. But since they give it to you under a category of Kadane's algorithm, everybody is going to write the same algorithm. So you would expect the runtime to be, pretty much the same. Complexity, it's O of n. So, used to analyze more. No, this is the first one I did today. Oh my God. I did one last night. I mean, I don't know. Are you counting that? Well, anyway, you can take my word for it. It's O of n. I mean, it's obviously O of n. It's just, we just do, one iteration through the array. That's it for Kadane's algorithm. I know that they have one more Kadane's algorithm tomorrow. But we know how to do it now. So thanks for watching. Hope you enjoyed it. Please feel free to like, subscribe, comment, and see you next time.